Okay guys, hello. And what we're going to do today is we are going to solve complex fractions. Okay, so complex fractions are just, they're exactly what they're called. They're complex. And what they are is they're just a fraction over another fraction. So we've got one whole big piece of fraction. Here's your line right here. And then you have a fraction right here, and you have a fraction and down here. So you have a fraction in your numerator, and you have a fraction in your denominator. Okay? One thing I want us to look at, when we've looked at fractions before, and I've said this many, many times before, every single fraction is just a fancy way of writing a division problem. So for example, if I have the fraction 3/4, that's just another fancy way of saying 3 divided by 4. Okay, that's all it is. It's just a fancy way of saying 3 divided by 4. Notice how I have my numerator comes first and my denominator comes second. Okay, so this is 3 divided by 4. 3 divided by 4. Okay, so notice the order of the numbers. That's exactly what we're going to do with complex fractions. I'm going to take my numerator, and I'm going to divide it by my denominator. Okay? So I have my numerator. I'm going to write that first. So I have 1/2 divided by my denominator. Okay? So we're going to put that second, which is 2/3. So I have 1/2 divided by 2/3. And then now from here, we can solve. Okay, so let's just scroll down a little bit. So I have 1/2, let me rewrite it, divided by 2/3. And then now we can just solve by just dividing. Okay, and when we divide fractions, one thing I want us to remember is we need to use the rules of keep, change, flip. So I'm going to keep my first fraction, okay? I'm going to change my division sign to multiplication, and then I'm going to flip this second fraction. So what this is really going to become is 1/2. So keep, change to multiplication, flip, times 3/2. And now I'm just going to multiply, and I'm going to get 1 times 3 is 3, 2 times 2 is 4, so my answer is 3/4. Okay, so what we started off with was 1/2 divided by 2/3. We started off with this big complex fraction, and that just changed into 1/2 divided by 2/3, which then changed into 1/2 times 3/2. Okay, so again, complex fractions are just a new fancy way of writing a division problem. So let's take a look at another example. Okay, so I have a new complex fraction. I have 7/8 over 7/16. Again, I'm just going to take my numerator and divide it by the denominator. Okay, so I'm going to take this numerator right here, which is going to be 7/8. Okay, and I'm going to divide that by my denominator, okay, which is 7/16. So this becomes 7/8 divided by 7/16. I need to follow my rules of keep, change, flip. So this actually becomes 7/8 times 16/7. Okay, and now I can just solve from here. And the cool thing about this problem right here is I can actually cross-reduce. If we remember how to cross-reduce, I can find a common factor diagonally. And so if I look over here at 8 and 16 right here, I can see that they both have a common factor of 2, 4, and they also have a common factor of 8. So I can divide by 8 to both of these. 8 divided by 8 is just 1. 16 divided by 8 is 2. And now if I look the other way, 7 and 7, if I look, they also share a common factor. They're the same number, so they share the common factor of 7. So I can actually divide both of these by 7. Those just cancel each other out and become 1. So now I just have 1 times 2 and 1 times 1. Okay? And that is equal to 2/1, which is just 2. So one more problem we'll look at. This one's a little bit different because now if you look at my numerator, so I've got here's my dividing line right here of my fraction. So I have my numerator and then I have a denominator. Okay? The process is still the same. This is just another fancy division problem. Okay? So what I'm going to do is I'm going to take my numerator and divide it by my denominator. Okay? So my numerator is 12. I'm going to divide that by my denominator, which is 2/3. So now I have 12 divided by 2/3. The process doesn't seem, just because my numerator is a whole number doesn't mean anything's changing. Okay, we're still doing a division problem here. And I'm still going to follow my rules of keep, change, flip. So this does become 12, change to multiplication, and then flip 3/2. So I have 12 times 3/2. Remember, if you have a whole number, you can always just put it over 1 if you want. Okay, so now it looks like a fraction. We can look at cross-reducing 1 and 3. I can't cross-reduce because 1's in its simplest form. Let's look at 12 and 2. They're both even numbers. 2 is the common factor. Okay, so I can divide by 2, divide by 2. This just becomes 1. This becomes 6. So now I have 6 times 3, 1 times 1. 6 times 3 is 18, 1 times 1 is 1, and that's all just equal to 18. Okay, and that's how you solve complex fractions, you guys. Again, they're just division problems, so really you're just doing dividing fractions, which actually just changes to multiplying fractions. So if you have any confusion on, if you are still struggling with dividing fractions, you can go back and watch the dividing fractions video. That will help you out. And if you're struggling with multiplying fractions, there's also a video for that as well.